Hi, everyone. Welcome to week 7. This week, we're going to be talking about the circulatory system. So let's get started. Oops, there we go. So before we get to the open circulatory system, remember to study the simple body plans before open circulatory system. So those are going to be animals such as the flatworms and the jellyfishes, the ones that have gastrovascular cavities that do gas exchange directly to the cells without any kind of liquid carrying the gases. So make sure to study on those, and let's dive into the open circulatory system. So open circulatory system, we're mostly going to be seeing this in arthropods and mollusks. So what makes it open is that they don't necessarily have veins and arteries running through the body. They just have the hemolymph flowing everywhere. They still do have hearts though, although they don't work as hard and pump as hard as the hearts we're going to see in the closed circulatory systems. It's going to take relatively less energy to do it, to pump the heart because of this. And we're going to be seeing these in arthropods and mollusks. So next, we're going to talk about the closed circulatory system. This is the first one we're going to look at is the single circulation. So it's going to be just one atrium, one ventricle. We're going to see this mostly in fishes. So remember, fishes, they don't have lungs, so instead they use their gills. So the heart's going to pump lungs to the gills. It's going to do the gas exchange, pick up the oxygen and release the CO2. And looking at the single circulation system, we're going to see that arteries aren't necessarily named arteries because they carry oxygenated blood. They're called arteries because they take blood away from the heart. So that's important to remember. And let's keep going. So next we're going to have the double circulation 3-chamber heart. So unlike the fishes, amphibians are going to have 2 atria and 1 ventricle. Another important thing to notice about amphibians and the 3-chamber heart is that they do have lungs, but they also have the option to do gas exchange through their skin. So let's say if a frog is underwater, they can shut off they can shut off the blood flow to their lungs and only do gas exchange through their skin so that they don't drown. And next we're going to look at the 4-chamber heart. So we're going to see this in mammals and birds. So, you, me, my dog Yuka, she has a 4-chamber heart. So we're going to have 2 atria and 2 ventricles. Oxygenated blood is going to be on the left side of the heart. Deoxygenated blood is going to be on the right side of the heart. And another thing that makes it unique is that crocodiles actually have a connection between the 2 arteries as they leave the heart. So this red circle here, they have a connection there. So it's very possible that during your test, I've seen it quite a good number of times where Bio5B professors, they'll put a question on the test where they'll say, which of the following has the correct or incorrect order of blood circulation. So it's good to know, familiarize yourself with the circulatory system, the human circulatory system. Be familiar with the names. A few things that can help is to just breathe in. You can breathe in. I'm sure she's doing it. So you want to breathe in, think about what's happening in your body. So as I breathe in, blood's going to flow from my heart. It's going to go into the pulmonary artery, because pulmonary means lung, artery means taking blood away from the heart. It's going to go into my lung capillaries. It's going to pick up oxygen. It's going to go into the pulmonary vein, because pulmonary is still going to and from the lungs, vein going back into the heart. And as I said before, it's going to go into the left side of the heart because oxygenated is on the left side. It's going to go through the atrium, then the ventricle, and it's going to go into the aorta or artery, go into the top part of your body, the bottom part of your body. Excuse me. And after that, it's going to go through the superior vena cava, superior, as in above, the above part of your body. Vena cava as in vein. Same goes with the bottom part of your body is going to be the inferior vena cava because it's below, it's inferior. And it's going to go back into the right side of the heart because the right side's deoxygenated. So it's going to go through the pulmonary, no, I'm sorry. It's going to go through the right atrium, right ventricle. And after that, since it's deoxygenated, it's going to want to go back into the lungs, dump out the CO2, pick up the oxygen again. So that's going to complete the cycle and go back into the pulmonary arteries. So if you do that a few times, it's not too bad. Looking at the diagram, it is pretty daunting, but if you go through it step by step, it's pretty manageable. So that's going to cover it for today's video.